All right, let's get started with the unit of probability and combinatorics in the pre-calculus course. All right, so for the first question, they're asking Cora is playing a game that involves flipping three coins at once. Let the random variable h be the number of coins that land showing heads. Here's the probability distribution for h. Where's the probability that Cora flips more than two heads? So we're not including more, which is only three. So that means our answer is only this thing, 0.125. 0.125. All right, so when registering their cars, owners must identify the color that covers the largest portion of the vehicle. In one region, the probability that a car was mainly white was 0.24, and the probability that it was mainly silver was 0.22, and the probability that it is mainly black was 0.19. In this region, are the events silver and black mutually exclusive? Like, the definition for this is that covers the largest portion of the vehicle. If the largest portion is already taken by silver, how can it black? How can it coexist? Mutually exclusive refers to the event where if you have one, you can't have the other. You can't have a silver car majority silver and also majority, because if one is majority, the other will inevitably be minority. So yes, they are mutually exclusive. What is the probability that you a random selected car from this region is mainly silver or mainly black? Well, that is the summation of the silver 0.22 and 0.19. We don't care about white. So 0.22 and 0.19 is 0.22 plus 0.19 is 0.41. So 0.41 should be our answer. Let's see. There we go. Which of these graphs does not show a valid probability distribution? Okay. So here we have x and probability of x. Here we have also x and probability of x. Okay. So an easy way to detect is the summation of all probability should be not be greater than 1. If it is greater than 1, that is impossible. You cannot have a probability greater than 1. So it does not show a valid probability distribution. So you have 0.5 plus 0.2, which is 0.7, plus 0.1 is 0.8, and 0.4. Whoa, it's greater than 1. 0.5, 0.1, 0.6, 0.4. This is also possible. This is possible. Let's see whether this is possible or not. 0.4 plus 0.3 is 0.7 plus 0.2 is 0.9, and this is 1. Okay, so now what do we actually select? Okay, does not show up. So our answer is A. These two are correct. Okay, so Yasmin and Hannah are designing a game. In each turn, a player rolls two dice, one seven-sided and one five-sided, and subtracts the number showing on each face to determine how many points they get that turn. All right, so you have got two dice, one the seven-sided and one the five-sided. Whatever number you have here, you subtract that with this one, and showing on each face to determine how many points. Okay, they get that turn. The game only looks at a positive difference. For example, if a player rolls 1 and 4, then they get 3 points. Let x represents the difference in any given turn, and they find the expected value of x is 2.14 points. Yasmin says, after a very large number of turns, the average number of points will turn to be 2.14. And Hannah says, over 1,000 turns we can expect. So expected value of x is 2.14. This is the points you expect in one term. So if you turn it for 1,000 times, you would expect to get an accumulated of 0. You know 2140 points. If 2.14 times 1,000 is 2140, then this is not correct. Hannah is not correct. So now whether Yasmin is correct or not, after a very large number of turns, the average number of points will per turn, yes, this is the expected value. So only Yasmin is correct. Jordan wants to play a basketball game at a carnival. The game costs the player $5 to play, and the player gets to take two distance shots. If they miss both shots, they get nothing. All right. If they make one shot, they get their $5 back. If they make both shots, they get $10. Jordan has 40% chance of making this type of shot, which means both of them are, are correct, or they get both shots Jordan has of these type of shot. All right, so 40% chance. Here's the probability of X, the number of shots Jordan makes in randomly selected game, and M is the amount of money Jordan gains from this game. So find the expected value of amount of money Jordan gains from this. So expected value is just the mean. Okay. Now here they're asking for money, so we don't care about X. We only care about this. So which is negative 5 into 0. 0.6. We're just finding the mean for expected value of X. So negative 5 into 0. 0.6, so negative 5 into 0. We have 36, plus we have, this is 36. And 0 times anything is 0, plus 5 into 0. 0.1516, sorry, plus 5 into 0. 0.16. So we have an expected value of negative $1. This is the. All right, so Ricardo and Maya and Nathan decide to flip 2 fair coins to see who gets to choose where they go for lunch. We have 2 fair coins, so which means the probability for each is half, whether head or tail. 2 fair coins. If neither coin lands showing heads, Ricardo gets to choose. What is the probability that Ricardo gets to choose? Well, it's 1 upon 2 into 1 upon 2, 1 upon 4. If exactly one coin land showing head, Maya gets to choose. And what is the probability? Exactly 1. It could be that the first one. What is the probability that the first one is, it could be head tail or tail head. First one is head, then tail, or the first one is tail, then head. This is the condition where you have exactly one coin that lands showing head, and Maya gets to choose. But if neither coin lands showing head, we have a tail, only one possible. If neither coin lands showing head, Ricardo gets to choose. This is the probability for Ricardo. But for Maya, we have 1 upon half, 1 upon 2 into 1 upon 2 plus 1 upon 2 into 1 upon 2. So you have 1 upon 4 plus 1 upon 4, which is 1 upon 2. 1 upon 4 plus 1 upon 4, you have 0.5. So Maya has a more chance. And if both coins land showing tails, so that is also tail half into half, which is 1 upon 4. Nathan gets to choose. Is this a fair bit to decide who choose where they should go? No, definitely not. Maya, it has, a greater probability, so Maya is more likely to choose. So it's not fair. Joe's is designing a game that involves flipping 3 fair coins and counting how many land showing heads. Here's a sample space, all possible outcomes when flipping 3 coins. Which graph represents the theoretical probability distribution of the number of heads? All right. So the probability distribution for number of heads. So 0 heads, all tail, 1 head, 3 possible, 2 head, 3 possible. Okay. So out of 8, 1, 2, 3, 4, 5, 6, 7, 8. Okay. So 0 head is 1 upon 8. This is correct. Not 1 upon 6. B, and what is this? This is not even a probability distribution table. A is our answer. Hey, I selected A. Anyway, that's the technical error. A mobile phone company gives customer the option for purchasing a screen protection plan. The customer pays $60 for the plan. Okay, so we have to pay $60, and if their screen is damaged, the company will replace it for no additional charge. The company knows that 8% of customers who buy this plan end up needing a screen replacement that costs the company $250. Here's the table that summarizes the possible outcomes from the company's perspective. So cost replacement, yes. Cost replacement, no. Net gain, okay. So we need to find X represents the company's net gain from one of these plans. Calculate expected net gain. So expected net gain, what is the probability that you would have, the customers will need, which is 8%. So 8 divided by 100 is 0.08. Now, if we replace the screen, you get negative 180, negative 190 net gain. So the probability that it will require is 0.08. So you have 0.08 into, we're finding expecting value of x, so that is the mean. 0.08 into negative 190, negative 190. And the probability that you don't require a replacement is 0.92. So that is 0.92. And when you don't require, the company is getting a profit, a net gain of 60. So into 60, the expected value would be 5.5, 5.52 minus 15.2, which is 40. 55.2 minus 15.2, 40. So I can say that the expected value is $40. There we go. Malik is a teacher who plays a review game with his class. The game involves writing each student's name on an identical slip of paper and selecting students at random. Here's the makeup of his class. Suppose that Malik speaks. Okay, so we have got 10th graded 6 students in 10th grade, 14 students 11th, and 5 in 12th. Suppose that Malik picks a name, replaces it, and picks. Okay, so he's replacing. So total number of papers is not changing, and we're picks a name again. What is the probability that both students selected are 12th graders? So what is the probability that first time you have a 12th grader? You have a total of 25 students. 6 plus 14 plus 5 is 25. 6, 14, 5. 6, 14, 5, 25 students. And you want a 12. So favorable outcome divided by total outcome, which is 25. And again, because you're replacing it back, the total number of paper doesn't change, and the probability remains the same that you have you selected 12th grader. So the probability that both are selected, you and that multiply. So 5 times 25 into 5 times 25, 5 by 25 into 5 by 25, 0.04, two decimal places, 0.04. All right. Mikkel runs his own business. He takes small groups of tourists on day-long tours of the city where he lives. He'll take up to 4 people at a time on a tour. Mikkel tracked how many people came on his tour in the last 200 days. Okay. So 0 people came in 6 tours, 1 people came in 14, and so on and so forth. Okay, so 6 days. So this would add up to 200. Based on this results, which graph represents an approximate probability distribution of the number of people on a random tour? So 0 will, number of 0 people, we can expect 6 out of 200. 6 out of 200. So that is probability of 0.03. Seems right, 0.03. So okay with 0. With 1, we expect 14 upon 200, which is 0.07. 0.07. Here we have more. See, here we have more than 1. If this is 0.2, this is 0.1. B cannot be our answer. 0.07. Okay, so if this is 0.5, then this can be 0.7, but this is almost equal to 1. Our C is our answer, but let's go and verify with 4. So for 4, you have 72 upon 200. That is 0.36. Here we have exactly 0.3. No, C is our. All right. Declan's friend Luca claims that he can read minds. To test Luca's abilities, Declan draws 5 cards without replacement from a standard deck of 52 playing cards. Declan then asks Luca to identify in any order which 5 cards he drew without looking. exact five cards. Assume that Luca has no special ability randomly guessing, where's the probability that Luca correctly identifies all 55 five cards in any order. So without replacement. So this means once you take it, you're not placing it back. So you're selecting five, and order matters in any order. So Declan then asks Luca to identify in any order. So order doesn't matter. You just have to guess the five cards. So we use combination and not um, permutation because order doesn't matter. We choose five cards from 52 to 52C5. But without replacement. So favorable outcome over total outcome. Five cards with a replacement from a standard deck of 52 playing cards. The clan asks to identify in any order which five cards you do without looking. Um, the total would be not A. Now, whether the question is B, C, or D, you choose. Uh, you have to choose all the five without replacement. In order which five he drew without looking. Okay. So favor total outcome is you choose five from this thing. So this denominator is okay for all of these options. Now, what is the favorable outcome? You have to choose the probability that correctly identifies all five cards. Okay. So you have to have the same combination of cards that was selected. So answer is B. Only one combination. This is the favorable outcome over total outcome. All right, for the last question, Kyra is a basketball player who regularly shoots sets of two free throws. Um, Here are some events and their meanings. Event S1 she makes the first shot, S2 she makes the second shot, SC1 she misses the first shot, SC2 she misses the second shot. Suppose that Kyra is going to shoot two free throws, considers probability. What does this thing represent in the context? So this thing means she makes the first shot and she also makes the first shot. And okay, the probability that makes, yes, the probability, because it's B, that makes both shots, because we have and. This is the answer and the end of our unit. So I almost got 12 over 12, except there was